Hey everyone, this is the Salem High School Robotics team. I'm be honored to join them, be the mentor with them. So today they will demonstration or introducing the new robot competition. Robot they just designed in a few weeks. So let's welcome. This is Stephen, Julie, and Ken, TJ. Yeah. Okay.
Welcome.
Welcome.
Hi, I'm Cameron. I'm our head of the manufacturing team at the robotics team. And this is KitBot. You can also see it in person, kind of tucked away in the corner back there. So I'm here to tell you what's KitBot, why do we do KitBot, and how do we do it. So KitBot is a sort of baseline robot that the company first sends to all teams at the start of each year, which kind of sets as like a baseline for people who may not have all the machines that would be required to make like a really competitive robot. So you have a starter point where you can iterate on later and make better. So this is meant to be able to play the game at a very basic level, but still be able to be like somewhat competitively viable. We chose to make KitBot this year for the purpose of teaching our newer students, as we have almost doubled our team size this year. So we're teaching a lot of the new students how to build it, as you can see up here and over there, because it teaches them how to build with instructions, as we're also sent the instructions as we will be making when we design our actual robot for the season. And we use a lot of basic equipment, drills, saws, to be able to really make this thing come to life here. And I'm going to pass it off to AJ now, where he will tell you that.
All right. Hi, I'm AJ. I'm a senior. I am the team's design lead. So for this year's design, we probably spent a good solid week and a half coming up with a robot archetype. So in years past, there's been very similar games. So there's generally two categories for games. There's pick and place and shooter games. Shooter games is where you have a game piece and you have to launch it into a game element. Pick and place is you have to pick up an item and place it on some sort of receptacle. This year, you'll see in the video later, where you have to pick up 4-inch diameter PVC pipes that are about a foot long and put them onto a series of pegs called the reef at, I believe, about 2 foot high, 4 foot high, and then a vertical peg at about 6 foot high. So to accomplish that, a lot of teams are going for, which is what we're going for, is an elevator approach. So day one, we were like, okay, we want to do an elevator, but how do we do it? So we used a program called Crayon CAD, which is that red and purple-ish robot you see on the left-hand side there. That is a rough approximation of what we wanted to get our robot to kind of look like. First, the company sends basically a 140-page document that says, this is what you can't do, and everything else is free game. So the limitations this year we had were height. The maximum starting configuration of the robot can be 3'6", but the robot can be as tall as it could be, as tall as you want it to be during the normal gameplay. It could be 25 foot tall if you really wanted it to be. So we had ran through really 4 main archetypes, which were an elevator that was at an angle, elevator that had 3 stages instead of 2 stages. We went through a bunch. We ended up deciding on this one, which was a 2-stage elevator, meaning that there was a fixed stage, a moving stage of the elevator, and then a carriage that would move up and down it as well, with an offset end receptacle. Basically, it's the thing that spits the coral onto these pegs you see here, here, and here. That's going to be offset from the carriage itself, allowing us to keep its, when it's compacted down into its stored configuration, it's under that 3'6" mark, but then it can go beyond its maximum height of the carriage when it's in its full extension. So right here is where we are right now as of, I think, last night. We have a rough drivetrain assembled, where we were very fortunate to get a new drivetrain module. We're on Swerve Drive, which is basically like spinny chairs in an office. It's like those but motorized. It allows us to have an omnidirectional movement, which is wicked fast. We got a brand new system from Swerve Drive Specialties this year, which is way better than the stuff we had last year. Our robots are going to be about 29 by 29 inches wide, and its starting configuration is, I believe, about 3'4". So we're pushing that max height a little bit, and its maximum height is going to be around 7 foot tall. So right now we're going to have the end receptacle. There is 2 rollers that are going to spin like opposite from each other. We have 2 little rollers on the left and right side that aren't powered. That'll just help center the coral, so it doesn't come out cockeyed. The next revisions will have a hopper on the back. That's just something we haven't integrated yet, to take in the coral from a human feeder station. And then we'll have an algae arm. Basically, there's 2 game pieces in this game. The second one is a 16-inch diameter kickball. So it's a really big kickball that start on top, like on these racks, on the pegs that you have to score on. So we have to try and remove them. So we're in the process of making a passive arm that, when it's in its stored configuration, springs back and is held back like this. But when the robot moves up, it springs out with a spring, and it's powered. So it's not actually, we call it degrees of freedom. We want to eliminate degrees of freedom as much as possible, because more degrees of freedom means more places that it can break, and that means to more tiers at competitions. So we're really proud of this design, because in its current configuration, it's 1 degree of freedom, which was incredibly hard to determine. And that was with hours of using that Crayon CAD software and figuring out, just changing slight dimensions to make everything work. And in the end, we're pretty happy with our archetype, as they call it. And next plans will be to add a climber. There's a climbing element to this game, which is basically a metal box that you have to pull your robot onto and pull it into your robot's frame. One is hanging from a overhead trough. One's hanging 2 foot off the ground. The other one is only hanging 3 inches off the ground. So we're going to try and climb onto the 3-inch tall one. So I'm going to pass.
I'll show you guys the video now in case you're confused on what's going on. So this is the game for this year.
Welcome to the 2025 First Robotics Competition game, Reefscape, presented by Haas. 2 alliances of 3 teams each compete to earn points by harvesting algae, seeding coral on their reef, and returning to their barge to ascend to the ocean's surface. Alliances earn additional rewards for meeting specific scoring thresholds and for cooperating with their opponents. Prior to the start of the match, teams can choose to hang a shallow cage or a deep cage on their barge. Robots start each match at their starting line and may be preloaded with 1 coral. During the first 15 seconds of the match, robots are autonomous and can be programmed to leave the starting line, remove algae from their reef, and place coral on their reef. If all enabled robots on an alliance leave the starting line and score at least 1 coral in auto, the alliance earns the auto ranking point. During the following 2 minutes and 15 seconds of the match, drivers control their robot. Robots can place algae in their net and collect coral from human players at their coral station to place on their reef. Coral placed higher on the reef are worth more points. If an alliance can score enough coral on all 4 levels, they will earn an additional ranking point. Robots can also deliver algae to their processor. Once processed, the algae can be taken by the opposing human player and scored into the net. When 2 algae are delivered to each processor, both alliances earn a co-op point. The co-op point reduces the number of coral needed on the reef to earn the ranking point and influences a team's rank in the tournament. As time runs out, robots race back to their barge to hang on their cage and ascend to the ocean's surface. Points are awarded to robots that can hang on a shallow cage, and even more points are awarded to robots that can hang on a deep cage. An alliance that scores enough barge points will earn the barge ranking point. The alliance that earns the most points overall wins the match.
robot. So the deep gauge, as you saw, only hangs 3 inches off of the ground. So we have to find a way to actually pull the robot and have its center of gravity be in a certain place. Game first Saturday of January, and we have until our first competition. Our first competition this year is week 2 of competition season, which is, I believe, March 7th?
Yes.
March 7th.
Okay.
So we have from then all the way till March 7th, but we get interrupted a week early by hosting GSD, which is our home event. And we meet Tuesday and Thursdays for 3 hours each day, and then Saturdays we meet for 8 hours.
And it's after school, and then Saturdays.
Yes,
obviously,
yeah, 5 to 8 on Tuesday, Thursdays, and then from 8 to 4 on
So that's
Saturdays. So it's
84 hours.
84 hours ish, yeah, from when we get the game to when we have to start competing. We compete at 2 events at the district level, which is, for this year, we're going to Greater Boston, which is hosted at Revere High School in Massachusetts, and UNH. So we'll be competing there. If we do well enough and we get enough district points, we'll be able to go to district championships, which is hosted in Springfield, Massachusetts. And then if we do well enough there, which the most recent time we did well enough to qualify for it was 2023, we can qualify to go to World Championships in Houston, Texas.
The actual robot will have
Somewhat
the
similar to
Exchange
get
Club
it
logo on the
through.
side.
And load
We
it
have a
to
sponsorship
our
panel. This is just our kit bot. How do you put it in the hand?
Just load it in the back, it's right. Yeah, so this robot is the thing that we get from the company. You get most of the parts, the drivetrain itself, complex rails,
So it'll just be a smaller
the
version.
radio and everything like that.
That will be
Put on the core. Yes.
Yeah,
They call that.
yeah. Yeah, this is the
And the way
pipe
they're
that we have
feeding
to
it
put on
is
it.
similar